I'm looking at my mapping again for this particular problem, just kind of mapping where the premises line up and who's connected to who and equations and stuff like that. Now I'm looking at my conclusion here, and well, Q and R don't have the direct connection. Wouldn't that be great? But they do share a T, so I might be able to go that route to somehow get to some equation that has an R or a Q in it. And then look at not S. So not S is kind of all alone. Now, it's not a part of the conclusion, but if for some reason we need to have a not S, we probably need to use modus tollens in order to do that. We've done that in a previous problem where we needed a negated symbol, or sorry, negated variable in order to reach it. So we've done that before. But that's how my overall mapping is going to look. Let's keep that in the back of our mind, that T might be the linchpin in all this. So as we get started here, I'm going to focus on that T because we needed that T to frankly get to, well, R and match between the Q and R. So there's a couple of spots of T's, but I'll be honest, I'm going to go with the easiest one, and that's going to be our Q implies our U and T. Now, I'm going to look at the two things here. I really want to split things up. We've done this before. How do I really get U and T by itself? Well, I get lucky again with modus ponens in getting number 1 and lines number 2 there on the table, break them up using modus ponens to get our U and T. Now that we've got that, we can use just simplification and get U, respectfully, and T. Basically, hey, we've got them set to true using, well, line number 3. So that's great. We've done that before too. So we have Q done, and now we really need to worry about the R part. And the R part, well, frankly, there's only one way of getting to that, and that's P and T. So we need to worry and focus on P and T because there's nothing, right now they're not soloed when it comes to being true, especially now that they have an implication of the R or S. So go figure. So we really need to start breaking that down. So what I'm going to do is I'm going to use a simple one for us at first here. And that's U implies P, because frankly, hey, we already knew that's true, and then maybe we get to use that and break that down into some simpler truths. That actually does. We can use modus ponens on line 4 and on line 6 to basically break things up and saying, well, wait a minute, I've already found U to be true, so P can be true because of modus ponens. So that helps me out a little bit. And now, because we found P to be true and T to be true, we can use conjunction on 5 and 7 to go ahead and make sure that our P and true is actually equal to true. So that's another part of that equation done. So notice I'm inching forward of that premise to get to the R. So far I've done the left-hand side, I've found that all to be true, and now it's the right-hand side. Now, I know that entire thing is true, so in line 9, I'm just going to introduce the premise saying, hey, I know this is true, but you know I got to start breaking things down, especially the right-hand side here in a moment. Now we have, well, we're able to use the modus ponens for lines 8 and 9. Now, I'm showing you a chart on how this all works out, but notice I'm doing substitution. Yes, this substitution is using both the P and T, implies the R or S. Try to say that 10 times over. So here we're able to break down at least the grouping of R or S is true. But as you know, we're going to have to start breaking that down further to get R to be true or S to be true. We have to figure that out from here on out. So as we normally do, let's go ahead and throw in the negated S as our premise because, again, I'm using that. Hey, I'm using every one of them for something. So if I use the negated S and you know that we have a negation that we're trying to figure out how we can get the R, here's a new one that you probably haven't seen yet, and that's disjunctive syllogism using 10 and 11. So you notice that it's going to break up that or that you and I really, really need in order to get that, frankly, that R by itself. Again, using our substitution that you're seeing here in this little chart here. But I'm able to get that R finally, and we're in pretty good shape here. This last part of all things is, well, your understanding of implications. Because our conclusion has an implication, if we found that Q is true implies that R is true, that is a definition of one of our items in implications, and basically has proven using lines number 1 in our chart a long time ago, and number 12, which is our use of our R to finally figure out that's equal to true. That's how we're going to use our whole setup in order to answer this problem. So it's a very weird ending on the end of that. So if you got most of this, you're in great shape. But that's that last part. Notice that conclusion had some type of implementation. Then you're going to have to prove that an implementation is good after you figure out all the truths for the variables that are